if you ran through the offices of Move2 in the past couple of days, you've probably come across one sentence or one string of words a couple of times. And this is command Z. Command Z sounds pretty mysterious and kind of cool actually. And yes, it actually is. So what we want to talk about is how command Z developed and what it is and what it looks like. But to start with this, we first have to learn a bit more about the ADCS system. And especially we will have to take a deep dive into how this is controlled and how it reacts to being controlled. This is kind of hard to understand, but we will try to make it as simple as possible. And I think the easiest thing for you to imagine it is with a carousel. You have to remember that Move2 is spinning pretty fast. The fastest point was at 530 degrees per second, which is like really, really fast, and you don't want to be in this position. And first we have to come down from the spin rate again, and we will try to do this with the ADCS system. And to come back to this example with the carousel, we will just imagine the following. I'm spinning right now, and when I want to slow down the spin, I have to decide in which direction I want to slow down. Because this is done on Move2, at first we measure the magnetic field, and then we make our calculations, and then we actuate the magnetotorquers, which will then run current through our coils and make us actually move or change our attitude. And what we are doing now is I calculate, I want to spin down, and I decide that I want to actuate my magnetotorquers in this direction. But right now it takes some time for me to make my calculations and save everything into my flash memory. So what I actually do is I actuate my magnetotorquers into, I was moving in the wrong direction. If I'm moving in this direction, I want to slow down and move my thrusters into this direction. But now, because I take this time to calculate everything, what actually happens is that I am 180 degrees too late, and instead of slowing down, I now remember that I wanted to move in this direction, and instead I speed up, because I have some latency inside of myself, and so I won't actually deaccelerate, but just accelerate even faster until I'm spinning with 530 degrees per second. And we can actually show this on a graph to you as well, as long as I'm not too dizzy. And how this basically looks is that it makes a curve like this. And what you can see here is the efficiency of our ADCS or our detumbling system on the y-axis, and the spin rate on our x-axis. And the red line just resamples how they both are connected. And this here is 0, and this here is the negative part, and this is the positive part. Here we are stable, and here we are unstable, which means if we get to this part where we are unstable, we won't be able to slow us down anymore, unless we make some changes to the satellite, or to the ADCS system in this case. And those changes are made with Command Z. I have also brought you a graph showing this in more detail. And what I just showed you on the paper is pretty much this blue line. Here we are still in the positive, stable part, and now here something is happening, and we need to pretty much change the signs of our ADCS system or magnetometers to make Move2 think it's moving in the right direction again, and basically make it the opposite, do the opposite of what it actually wants to do. And this is what command Z does. And command Z looks something like this. It is, here you can see the first command that we sent. This is the bus call. This basically sends sends a command to one of our daemons, in this case the ADCS daemon, and then we tell the daemon to update its parameters. But to really update the parameters, we also need to plug in some new parameters. And we do this with this line here. Basically, we say we want to update the parameter number 63. And then we want to update 6 numbers in those parameters. And now comes the real interesting part and the most important part of this command set. And those are these 3 numbers. You have to imagine that we are scaling our magnetometers. And we get an output from them. That is, you can pretty much just imagine this like a linear function. And then you have some mx plus z, or whatever you want to call it. And this m just scales the x, and the z are just parameters that make everything move into the right direction again. And what we are basically doing is our m is usually just 1. But now we make it minus 1, minus 1, minus 1 for the x, y, and z axis of the satellite. This basically makes the signs the opposite of what they were before, so plus becomes minus and minus becomes plus. And we can leave those parameters at the end unchanged because, but that's quite complicated, we pretty much don't need them. And basically, what everything comes down to in command Z, this whole thing is command Z, like I said, are those 3 numbers. This is everything we do and everything we need to do to slow down the satellite again and to make us go into nominal mode and help us stabilize everything again. So now you know what command Z is. I think it's actually quite interesting because it, on the one hand, sounds pretty cool. Oh, and I can also tell you why it is called command Z. That's because it's a command you usually never want to make in space, because it will make everything go wrong and instead of slowing you down, make you spin up. Unless you're already spinning fast enough for you to make it slow down again because of the latency. Then I think I've got nothing more to tell you really about. If you have any questions about this topic, ask them in the comment section. And thank you for watching this video.